Alright, so moving on, we're on chapter R.4 now, which is equations. And let's see, what have we done so far? We've just looked at expressions, right? We've looked at functions, polynomials, how to factor them and whatnot. An equation is when you throw in an equal sign, right? When you ask, when does one expression equal another expression? And we'll start off with perhaps the most simple type of equation. A linear equation is one where you can, maybe it's not necessarily given in this form, but you can rearrange it to this form. If it can be written in the form ax plus b equals 0. Right, so where a and b are just any old numbers, although I guess if a is 0, it's not very interesting, so a is not 0. And we'll do an example. I'm sure you know how to solve linear equations, but we'll just do a simple one very quickly. Solve, here's a linear equation, 3x minus 2 equals 0. Right, in this case a is 3 and b is minus 2. So I want to solve for this, right? I want to find the value for x that makes this true. Right? X is a variable. You can think of plugging in all sorts of numbers for x. I'm asking which value for x makes this true. How do we solve this? Well, what do you usually do? I want to isolate x, right? So I'd want to get this 3x expression by itself. So let's add 2 to both sides. This means 3x. If I add 2 to the left and add 2 to the right, I'm left with 3x equals positive 2. Again, I want to continue isolating x. Well, I've got this 3 that's multiplying it. So let's divide both sides by 3. Right? So if I divide the left by 3, I just have x. If I divide the right by 3, I have 2/3. And there's my solution. X equals 2/3. You can come back here and check this if you want. Plug in x equals 2/3, and I've got 3 times 2/3, which is 2, minus 2, does indeed equal 0. It's a true expression. Okay? So there's our solution in this case. And before we move on to the next type of equation, I just want to do one more example. Let's say solve 2x plus 5 equals 3x plus 2 times 1 plus x. Alright, so this one has a lot more going on. It doesn't look like a linear equation, but I promise you it is. I promise you that if you rearrange this enough, you could get this in the form something times x plus some constant equals 0. Alright, so I want to solve this. What do? As usual, I want to isolate x, right? I want to get x by itself. So first thing I probably need to do is expand this piece to get this x sort of out of these parentheses. So let's just, we'll leave the right hand or the left hand side the same. 2x plus 5 equals, here I've got 3x plus, now we expand this. 2 times 1 is 2, plus 2 times x is 2x. What now? Well, I'd probably want to group these x's together, right? So let's do that. We've got 2x plus 5 equals 3x plus 2x is 5x plus 2. Alright, so now I want to group all the x's on one side. To avoid negatives, how about we move the 2x over to the right? Right? If I subtract 5x from both sides, I'm going to have a negative over here. So we'll just move x to the right. No problem with doing that. So I've got 5 is equal to, subtracting 2x from both sides, is equal to 3x plus 2. And now, this is the exact same equation as I started with, it's just in a totally different form, but it still is an equivalent expression. And it's in a much simpler form, right? Now I'm just going through and simplifying this to make it easier to solve for x. Now I want to isolate to the 3x, so we'll subtract 2 from both sides. Subtracting 2 from the left gives me 3. It's equal to 3x, which means x is equal to 1. And as always, you can check this. This is the nice thing about solving equations, is you can always check if you're right. Just take x equals 1 and plug it in up here. We've got 2 times 1 is 2, plus 5 is 7. 7 on the left is equal to 3 times 1, which is 3, plus 2 times 2, which is 4. 3 plus 4 is 7. So indeed, if x equals 1, we have 7 equals 7, which is a true expression. So we've solved the equation. Alright, next up we've got quadratic equations. An equation is quadratic if it can be written as, or in the form, ax squared plus bx plus c equals 0, right? So instead of just having something times x plus some constant, like a linear equation, I've got an x squared term in here as well. And once again, I'm going to require that a is not 0, because if a is 0, what happens? Well, 0 times x squared is 0, that term just goes away, and I'm left with a linear expression, right? So a has to not be 0 for this to actually be quadratic. And what we want to talk about is solving these things. And it turns out with quadratic equations, there's sort of two methods for solving. And so two methods for solving. Method one is just factor. Alright, so our first method is factor this quadratic equation if we can. So for example, let's do one here. Let's say solve the quadratic equation 2x squared minus x minus 3 equals 0. Okay, so what do I have on the left? On the left I have a polynomial, and we've talked a lot about factoring polynomials, so let's see if we can factor this. Unfortunately, it's a tricky case where I don't have a 1 in front of my x squared, so I'm going to have to deal with that. Well, 2 isn't bad. The only way I can get a 2x squared is if I have 2x times x, right? 2x times x gives me 2x squared. And now I'm looking for two numbers that multiply together to give minus 3, and when I put them in here and I distribute, I end up with a minus x term. Well, there's not many ways you can get minus 3. You can do minus 1 and positive 3, or minus 3 and positive 1. So let's try this. Just looking at how this is going to distribute, how about we do plus 1 here and minus 3 here. Right, and I think that works. We've got 2x squared, we've got minus 3 as our constant, and then if I distribute this out, I've got 2x times 1 is 2x, minus 3x is indeed negative x. So that does factor. This factors exactly like this. And now here's an interesting mathematical fact. I have two numbers that are multiplied together, right? It's written in the form of this variable x right now, but as long as once you plug in a value for x, both of these are numbers, right? So I've got two numbers multiplied together, and a mathematical fact says that the only way two numbers can multiply to give you 0 is if at least one of those numbers is 0, right? So here's the fact. If a times b is 0, if I have two numbers that multiply to give me 0, then a equals 0 or b equals 0, or possibly both. That can happen as well, right? But a really nice fact about real numbers is that the only way two numbers can multiply to give 0 is if at least one of them is 0 itself. So here I'm claiming that this equals 0, so at least one of these numbers has to be 0, right? So either 2x minus 3 equals 0, or x plus 1 equals 0. Well, if x plus 1 equals 0, I'm doing this one first because it's the easier one. If x plus 1 equals 0, what does that mean x is? Well, let's isolate x, right? Subtract 1 from both sides. X equals minus 1. There's one solution. Or over here, I'm running out of space, so I'll do this all in one step. We'll do two steps in our head. Add 3 to both sides, so I have 2x equals positive 3, and then divide by 2. So x would be 3 halves. And as always, you can check these. You can come back to your original equation, you can plug in minus 1 or 3 halves and check that it works. I'm not going to because the numbers will be a little bit ugly, but I promise you that if you plug in minus 1 or 3 halves for x, you will indeed get 0 on the left. Okay, so this is the method of factoring. One very important thing here is that I have 0 on the right-hand side, right? And I need 0 on the right-hand side so that I can use this fact, so that I have two numbers multiplying together to give me 0. If you're given an equation where you don't have 0 on the right-hand side, just move it over, right? Move everything to the left so that you do have 0. Alright, so really quickly, here's an example of something that I was talking about there, something like 2m squared plus 7m equals 15. Right, so this is a quadratic equation because if I move the 15 over, it will be in the right form. It will be the form ax squared plus bx plus c equals 0. And I have to do that before I try to do any sort of factoring. I need 0 on the right-hand side, so I'm just going to modify this. We're going to subtract 15 from both sides to get 0 on the right. And now I'm going to try to factor. It looks very similar to the one we just had. I've got a 2 up front here, so the only way I can get a 2m squared is if I have 2m times m. I want two numbers that multiply together to give me minus 15. We can either do 1 and 15 or 3 and 5. Let's try doing 3 and 5. Yeah, this is going to work, I think. We'll do a plus 5 here, right? That'll give us 2m times 5 is 10m. And then if I do minus 3, we'll subtract off 3 m's and get 7. Alright, so this is factored, and once again, this means either 2m minus 3 equals 0, or m plus 5 equals 0. And this one gives me m equals minus 5, and this one gives me m equals 3/2. Alright, so there's the method of factoring, right? You just have to move everything to the left so that you have the standard form of a quadratic equation equaling 0, and then try to factor if you can. Here's the problem. You can't always factor. Let's say you can't always factor it, right? Sometimes you'll try to factor and you'll just look at it, and there's no easy way to factor your expression. All right, so here's method 2. Method 2, and this is a really nice method again because it will always work for you. Sometimes you can't easily factor, but if solutions do exist, this will find those solutions for you. It is the so-called quadratic formula. Alright, so the quadratic formula. And what it says is this. It says if you have a standard quadratic equation, if ax squared plus bx plus c equals 0, then your solutions are always of the following form. This tells me immediately what x is going to be, right? So then x is equal to minus b plus or minus the square root of b squared minus 4ac over 2a. Right? And there's the quadratic formula. Right? What are a, b, and c? Well, a, b, and c are based on the coefficients in the actual quadratic equation, right? A is the coefficient of x squared, b is the coefficient of x, and c is the constant term. But again, I want to remind you that it has to be in this form first, right? It has to be a standard quadratic equation equals 0 before you start reading off a, b, and c. But this is really nice, right? It says I don't actually have to go through this factoring process. You should factor if it's easy. If it's easy to do so, that should be your first go-to technique. But if you can't see how to factor it easily, that's okay because a quadratic formula will come to rescue. It will tell you immediately what your solutions have to be. You'll notice there's two solutions here, right? Plus or minus the square root, so you do the plus to get one solution and the minus to get the other. The only time you don't have two solutions, you might only have one if the square root is 0, right? Because plus or minus 0 is the same thing. And you can actually have no solutions at all, right? Sometimes quadratic equations don't have any solutions at all. If this expression here, b squared minus 4ac, if that's negative, right? Because you can't take the square root of a negative number. So let me just point this out. No solutions if b squared minus 4ac is less than 0. That less than sign looks a whole lot like a c, so it's less than 0. So we'll do an example. Solve 3x squared plus 2x minus 4 equals 0. Alright, standard quadratic equation, a is 3, b is 2, c is minus 4, and it's equal to 0 on the right, so we're good to go there. And your first thing, when you look at anything like this, your first go-to technique should be, can I factor this? Unfortunately, if you try to factor this, you'll struggle, because finding the right numbers to go in the factorization is really hard to do. They're not nice whole numbers or even nice fractions. Alright, so instead of doing that, I'm going to go straight to the quadratic equation. I'll note that a is 3, b is 2, and c is minus 4. Right, remember it's with the form plus c, so it's plus minus 4. A is 3, b is 2. And we'll go straight to the quadratic equation. X is minus b, so minus 2, plus or minus the square root of b squared, so 2 squared minus 4 times a times 3 times c times minus 4. I'll put parentheses around all of those. And I'm forgetting something, all divided by 2a. 2 times 3. Okay, so this is minus 2 plus or minus the square root of 4 minus, what do I have here? 4 times 4 is 16, times 3 is 48, minus minus becomes plus 48, all over 2 times 3 is 6. And the last thing I would do is, of course, write this as a single expression. 4 plus 48 is 52. And maybe I want to sort of separate my two solutions, right? So x is minus 2 plus square root of 52 over 6. Right, there's one solution. Or x is equal to minus 2 minus the square root of 52 over 6. And there's another solution. And there's my two solutions to this quadratic equation. Really, really nice formula because I don't have to factor if it's really hard to factor. I can just use this formula and it tells me the solutions if they exist. And if they don't exist, you'll realize immediately they don't exist because you've got something negative inside the square root. By the way, be really careful with MyMathLab when you're entering these things in. This is the exact answer. You can put this in a calculator, it'll give you a decimal approximation out to as many decimal places as you want, but quite often MyMathLab does want the exact answer. So unless it specifies that a decimal approximation is okay, this would be the solution it's looking for. Well, either solution, both solutions really, but it wants it in the exact form. Alright, we'll try another one. Let's see, solve 6 squared plus, or sorry, z squared plus 6 equals 8z. In my classes, I really like to give the students time to try a few problems on their own, right? I try not to just lecture through the entire thing. So if you want, I mean, pause the video here, try and solve this on your own, see where you get, and then unpause it because I'm about to keep going with this problem. So, let's see. It's not in standard form right now, right? It's not 0 on the right-hand side, I need a 0 over there. So let's manipulate this. Let's subtract 8z from both sides to put it in this form. Okay, now I'm going to try to factor this. I want two numbers that multiply together to give me 6 and add together to give me -8. So I highly suspect I'm multiplying two negative numbers together to get a negative number when I sum them. In fact, that's a necessary property of addition. So what can I do? I could do minus 3 and minus 2, but minus 3 and minus 2 would just be minus 5, not minus 8. Or I could do minus 6 and minus 1, but that's still just negative 7. So there's no easy way to factor this, if a factorization exists. So we'll go straight to the quadratic equation, because it's in the right form now, right? It's 0 on the right. So z is going to equal minus b. b is minus 8 in this case, so minus b is positive 8, plus or minus the square root of minus 8 squared minus 4 times a, which is 1, times c, which is 6, all over 2a, 2 times 1. So I'm looking at 8 plus or minus, what do we have? Minus 8 squared is 64 minus 24 over 2. So our two solutions are z equals 8 plus the square root of 40 over 2, and z equals 8 minus the square root of 40 over 2. By the way, it is true that there's a whole lot more simplification I could do here. If I wanted square root of 40, I could write that as 2 root 10, and then I can divide top and bottom by 2 I could just carry through this division by 2. It would make the answer look a whole lot prettier, but that's fine, right? My math lab will accept this answer, and this one as well. It's just in that form. You don't have to fully simplify it unless it really specifies. So we'll leave our answer just like that. All right, last up, different types of equations. Equations with fractions. Right, what do I mean? I'll just go with an example. Something like solve x over 3 minus 5 halves is equal to 6 minus 3x over 4. Right? This is not a linear equation, though it simplifies to something linear eventually, so it technically is a linear equation. But how do we get it to look like the linear form? And the answer is, when you're dealing with these types of equations like this, with fractions, what you want to do, there's actually lots of ways you could proceed. The way I'm going to proceed here might actually be a different order than the way the textbook does it. You can do lots of different things. What I tend to like to do is I want to combine everything on one side into a single fraction. Right, so this is my technique. Let's combine fractions into a single fraction on each side, if necessary, using a common denominator. So I want to combine these into a single fraction. I need, right, on the left I've got x over 3 minus 5 halves. I want to write this as just a single expression. And we worked with fractions, what section was it? R.3, I think, maybe? Yeah, rational expression was R.3. It was the very last section. I want to put these over a common denominator. So common denominator between 3 and 2. Well, least common multiple of those would just be 6. So we'll go with 6. Alright, so I want the bottom here to be 6. So what do? I need to multiply the bottom by 2. Let's see, we'll go with this side. I want to multiply the bottom by 2, but I'm not allowed to just freely multiply the bottom by 2. If I multiply the bottom by 2, I better do the same thing to the top, right? So that it stays the same value. It just stays as x over 3. And over here, I want the bottom to be 6, so I'm going to multiply the bottom by 3, and that means I need to multiply the top by 3 as well. So on the left, this is actually now 2x over 6, and this is 15 over 6, or as just a single fraction, 2x minus 15 over 6. Great, so that's the left. I'm going to do the same thing on the right. I want a common denominator over here. Well, I haven't written this, but it's really, when you write 6, it's really 6 over 1, right? So I want a common denominator, least common multiple between 1 and 4 is 4. So we'll multiply the bottom by 4 and the top by 4. And over here, I would never really write this, but multiply this by 1 on top and bottom, right? So now they're both over 4. I've got 4 times 6 is 24 over 4 minus 3x over 4. And if I combine these into a single fraction, which I'm allowed to do now, I've got 24 minus 3x over 4. So what now? Well, as always, I want to isolate x, right? That's my end goal. So what do you do now that I've got one fraction equals another fraction? The way you solve these types of expressions or equations is you cross multiply. All right, so step 2 is cross multiply. To clear out the fractions. Right, what do I mean by that? Well, I want to get rid of the 6, so I'm going to multiply the left-hand side by 6. Be careful, that's everything on top is multiplied by 6. And if I multiply the left-hand side by 6, to keep it balanced, I better multiply the right-hand side by 6. Right, so what happens? Well, those guys cancel. I also want this 4 to go away, so I can do the exact same trick. I'm going to multiply the left-hand side by 4, right? And that will make that 4 on the bottom there go away. And to keep it balanced, if I multiply the entire the entire right-hand side by 4, I better multiply the entire left-hand side by 4. What does that mean that I'm left with? Well, these 6's canceled, so I've got 4 times 2x minus 15 is equal to, those 4's canceled, so I've got 6 times 24 minus 3x. And now it looks like a whole lot more manageable of an equation to solve, right? I still want to try and isolate my x's, so I better expand this stuff out. I might run out of space here, we'll see how this goes. 4 times 2x is 8x, minus 4 times 15 is minus 60, is equal to 6 times 24, 6 20s is 120, plus 6 times 4, that's 148. Actually, 144. Yeah, 12 times 12. Minus 18x. Alright, we'll group all the x's on the left. We'll add 18x to both sides. 8 plus 18x is 26x. And we'll add 60 to both sides. So adding 60 to the left gives me 0 over here. Adding 60 to this side gives me 204. And that means x is 204 over 26. How many times does 26 go into 204? I had to rack my brain for a second there trying to divide 204 by 26, but it's not going to go exactly. So x is just 204 over 26. And one thing you could do is you could factor a 2 out of the bottom and a 2 out of the top. So if I simplify this a little bit further, this would be 102 over 13. Right? Just pulling a 2 out of here, right? This is 2 times 13 and 2 times 102 and canceling the 2's out. But this unfortunately doesn't simplify any further. So the answer is 102 over 13. And you'll notice that what we did here is, we started with a complicated expression, but this is what you should always do when you have these fractions. Combine both sides into a single fraction to get down to here, and then cross multiply to cancel off the denominators. So it really becomes a simple linear equation, or it might be quadratic or something in a harder example, but In this case, it just became a simple linear equation. Alright, I have a few more examples written down, but this video I think is getting pretty long at this point. So let's just do one more. We'll solve this equation. 2y over y minus 1 is equal to 5 over y plus 10 minus 8y over y squared minus y. And so actually quite a bit more complicated than the example we just did, because it involves this y squared term, so I've got quadratic stuff going on. But we'll use the exact same algorithm. Combine both sides into a single fraction. Well, the left-hand side is already a single fraction, so nothing that I need to do there. And then on the right, I want a common denominator for these two fractions, so I can combine them. And one thing you could do is you could just freely multiply. You could say, okay, well, common multiple between these two would be y times y squared minus y. So I'd multiply top and bottom here by y squared minus y, top and bottom here by y. But try to think ahead before you do stuff like that. All right, what I could actually do to this expression is I could factor the bottom first, right? And this factors as y times y minus 1, right? Which means if I'm putting these over a common denominator, well, the least common multiple between y and y times y minus 1 is y times y minus 1. So all I really need to do here for this expression is multiply top and bottom by y minus 1. And now they're both over the same denominator. Cool. So we've got 2y over y minus 1 is equal to, we'll just combine them now, right? They're both over y times y minus 1. So this will be 5 times y minus 1 plus 10 minus 8y over y times y minus 1. Alright, so I want to cross multiply to clear this of fractions, so we'll multiply the left-hand side by y minus 1, and that will cancel out this y minus 1, and we'll multiply the right-hand side by y minus 1. But if I multiply the whole right-hand side by y minus 1, that also cancels out this one as well, right? Multiply both sides by y minus 1, and these two denominators go away. And then I want to multiply the right-hand side by y. Right? Everything here multiplies by y, so those cancel. And we'll multiply the left-hand side by y. So we've got 2y squared is equal to, we're going to distribute this as we go, 5 times y minus 5 times 1 is minus 5, plus 10 minus 8y. And I don't want to squeeze stuff in over here, so I think I'll just erase some of this. We only really need this last line. And so bringing this all the way back up, we've got 2y squared is equal to 5y minus 8y, it's minus 13y, nope. 5y minus 8y is minus 3y, sorry. Minus 5 plus 10 is plus 5. So this is a quadratic equation. It's not in the standard form though. I would need 0 on the right. So we'll just move everything to the left. 2y squared plus 3y minus 5 equals 0. And we could try to factor this. So let's go ahead and try and factor. The only way I can get 2y squared is 2y times y. And I need two numbers that multiply together to get minus 5. There's only two possibilities, plus or minus 1 or plus or minus 5. And when I distribute, I get plus 3 in the middle. Let's see. I think this will work. I think we can do plus, is it going to work? Minus 1 plus 5. That works, yeah. Right? We've got 2y squared, we've got minus 5 as our last term, then we've got minus 2y plus 5y is positive 3y. So last but not least, 2y plus 5 must either equal 0 or y minus 1 must equal 0. This is the easy one. Y equals 1 is one solution. Or this one, 2y equals minus 5, so y is minus 5 over 2. So there's our two solutions. And this video has gotten pretty lengthy at this point, but equations like this, again, you'll be doing stuff like this in calculus, right? And this is what I said in sort of our introduction video, is it's this type of algebra that throws people off. It's usually not the calculus itself, it's not the differentiation or the integration that's really the hard part. It's manipulating expressions that look like this. So try and really become a master of this stuff and you'll find this course a whole lot easier, I promise. Oh, I'll say one more thing. The next section, R5, coming after equations, is inequalities, which are basically equations where instead of having an equal sign, you have an inequality, right? Less than or equals or greater than or whatever. And we're going to skip that review section just because, one, in the interest of time, and two, we won't actually work with the many inequalities in this class. They will come up, right, but not that often, so in the interest of time, we'll skip it, but I would recommend reading through the section because being able to solve inequalities is slightly different than solving actual equations. So anyway, yeah, we'll stop here. Thanks.